So you don't need to waste. If you have been following us here on this channel, then some things you should be able to do some things now. You should not waste yourself doing titration 24 times, 3 times. You don't have a whole lot of time. Because in chemistry, you are answering all questions. And time management is very, very important. So this is my indicator. I'm putting two drops. Okay. So this is it. 1 and 2. You can see the color change now. So let's have. So you can see my burette reading is on 0.00 now. So let's have the titration. Let's go now. Let's see. Gently, because I'm feeling like it will change. I can see I'm going in drop now. You can see in drop. Let me take my readings. So now look at that. I said I want to do it once now. Hello guys, you're welcome to today's class. This is Chemistry Hangout, and today we're going to be looking at the volumetric analysis for this year WAEC examination. We're going to be looking at the volumetric analysis. Very important. Let me quickly say this. On this channel, what we do is predictions. Because of our expertise in the field and because of how much we have been in the field for some time, seeing those reagents, we can now see how the questions might look like. There is nobody here that is saying that this is the exam question on that day, or this is the real question you are going to be seeing. Of course, we thank God that has been helping us to predict a lot of questions in previous years, but it doesn't mean that this is the question on that day. Our own is to guide you. Our own is to build your confidence. Our own is to do the practical here and give you a lot of tips to pass the exam on that day. I want to believe that is very clear. So, and that same thing we are going to be doing year in, year out. So our own is pay maximum attention to our instructions here, adhere instructly to what we are saying, and we are sure that when you come out of the exam hall, you are going to come out smiling. So please pay maximum attention to this class. I'm going to, give a lot of tips like I always give. I'll give a lot of instructions like I always do. And I will give a lot of warnings like I always do. And I believe that you guys are going to excel in your exam. So today, very quickly, let's look at the predicted question for this year exam. Let's look at it for the volumetric analysis. Let's look at it. It said A is 0.100 mole per dm cube of HCl. B is obtained by diluting 50.0 centimeter cube of saturated solution of NaHCO3 at 25 degrees Celsius to 1 dm cube of distilled water. Okay. Put A into the burette and titrate it against 20 or 25 centimeter cube portion of B using Meti orange as the indicator. Now listen, the reagents they gave us this year can cover a wide range of topics. Yes, can cover from solubility to molar mass to concentrations to mole. A lot of questions can be asked. That's the reason why my predicted question, I try to compress everything together so that any angle that they are coming from, you can always tackle the questions. Just listen strictly to what I will be saying. And very important too, my title value here does not hold grant in your school. Yes, I am not the chemistry teacher in your school. A lot of students that are watching this and you say, oh, the title value of chemistry hangout is this, the title value of my school is different from the title value I saw. That is none of your business as a student. The title value of your teacher holds ground in your school. However, the calculation remains the same. The way we are going to calculate it will remain the same. The only thing that will be changing is our value. So I'm giving a strict warning to students. Please make do with the title value in your various center. I repeat, students, make do with the title value in your various center because your chemistry instructor is going to be giving a report to fill. And of course, they're going to mark every center based on the title value that your chemistry teacher actually wrote. That's the first thing. To my co-educators, my my co-chemistry teachers, I've seen a lot of people comparing title value. That is not necessary. You are the chemistry teacher in your school, and for everything you fill in your report will be used to mark your school. So there is no problem about title value or no title value. You might not be getting the same. The purity of the salt might not be the same. The way we have prepared it might not be the same. So make do with the title value you feel is okay for your center, irrespective of my own. You can decide to use my own, it's fine. You can decide to use your own, it's fine. Just make sure that your students are working with the title value you are using in your various centers. And that's why I said I'm going to be giving instructions, I'm going to be giving warnings so that we do well in this very particular exam. So now, let me quickly correct something again. Very important. Let me just do this correction. Very important. A lot of students makes mistake in burette readings. And I want to show you something here. You should understand that the way the burette readings is calibrated. Look at something. I will see some students writing 24.33 centimeter key as burette reading. This is not possible on your burette. It's not possible. You can only have 24.10, 24.20, 24.30 because the calibration of our burette is 0.10. So you can have this as the average, meaning when you have added some of the titles together and you divide by 3 or by 2, depending on what you did. That's how you can add this. But in your burette readings, please, 24.10, that's how it is calibrated. Please, we need to know all this because the marking will start from the table. Yes, the marking will start from the table. Now, very quickly, I'll just do one titration today. If you have been following my channel, you should understand titration. If you are just new to this channel, you can check our other videos. I will show you how you can, you can quickly compute your tables, because this will waste your time if you are not very careful. I'm going to do the title value I'm going to do the titration just once, right? Then, so that when you are giving title value or you are working with the title value, you know how to fill in your table without wasting much of your time. You get that? So that you don't waste time on that day. So we'll do just only one. Now, look at this. This is the base. I've already filled my burette actually. So we have been doing this on this channel for a while now. So this should not be a problem. So for students, please pay attention to this. Pay maximum attention to this. Okay, this 25 now. Do you see that? So let me have this here. So you don't need to waste. If you have been following us here on this channel, there are some things you should be able to do some things now. You should not waste yourself doing titration 24 times, 3 times. You don't have a whole lot of time. Because in chemistry, you are answering all questions. And time management is very, very important. So this is my indicator. I'm putting two drops. Okay. So this is it. 1 and 2. You can see the color change now. So let's have. So you can see my burette reading is on 0.00 now. So let's have the titration. Let's go now. Let's see. Gently, because I'm feeling like it will change. I can see I'm going in drop now. You can see in drop. Did you see that? So now let me take my readings here. Let me take my readings. So now look at that. I said I want to do it once now. I'm getting around 24.00. That's what I'm getting. Now look at this. I want to teach you how to compute your table. I've done it once. I'm getting 24. And you know I have to fill all these things. What do? You don't need to waste your time. And that's why you are here to learn a lot of things. So for our initial readings, I'm saying that I started from 0.00, which means after every titration, I refill the burette, right? So I can have 0.00, 0.00, 0.00. Did you see that now? Now, I want to use 24. Did you get that now? like what I got first. So how do I arrange my table? I don't want to do the practical 3 times because of time. Did you get that? You just have to be smart. So what do? I can increase this value, you know, for rough. Rough is saying that, you know, maybe I didn't wash my burette well, my pipette is dirty and the rest. So I want to increase this value by 0.20. Did you get that now? So I can say my rough is 24.20. Did you see that now? Now this is my rough, 24.20. While my first and second, I can say this is 24.00. This is 24. I'm done with my table. I don't know if somebody is here. Let me give another example. At your center, you are using maybe let's say 25. Just an example. They said, okay, let me give this one so that I will not be giving a round figure. Let's say, for example, you are using 25.10. Look at what you are using. Let's say this is what you are using in your center. Very simple. And you know, some students will do rough, first, second, and third. It's still the same thing. What will you do? This is what you are using at your center, right? For the rough, make it go up a bit. Did you get that? So I can exactly say, oh, my rough is 25.30. Did you see that? For my rough. My first is 25.10. My second is 25.10. My third is 25.20. Did you see that now? But listen to this. Very important. You will see when I'm using rough, first, second, third, 2 out of the value are the same. That's what we call a concordant value. There are marks for this thing. You can see when I'm using 2. Did you see? When I'm using 2 of the values, the 2 is the same because I'm using rough, first, second. A lot of students will use rough, first, second, third. We are still saying the same thing. Do you understand? But look at my first and second. When I'm using just 3, it's the same. But for people that are using 3, did you see? This and this is the same. Then this is a bit up by 1.0. By 0.10 rather. Did you get that? These are ways you don't need to waste time on your titration. You can say I just did once and I've computed my table. I hope that's clear. Let's do one example again. At your center, you are giving, peradventure, you are working with 23.80. Did you see that? 23.80. That's what you are working with. What's the idea? Make it go up by 0.20. Make it go up by 0.20. So if I add 0.20 to this, it will give me 24.00. Is that okay? That will be my what? That will be my rough. Then what I'm working with, 23.80. Again, 23.80, 23.90. Did you see that now? Can you see these two? They are what? They are the same. So when I want to get my average titre value, this plus this plus this divide by 3. This plus this plus this divide by 3. We are still going to be within the range. Let me say this, and I know a lot of people will like this, but they like shortcut. But you know, we're just teaching you to be smarter. We know what it will look like if we do all these things. So there is no need to waste our time. Another one, sometimes, look at it. Let's say, for example, you are working with 22.33 centimeter key. A lot of students will miss a lot of things here. Because some will now come and say, oh, they asked me to go up by 0.20. You now come and say, your titre value is 22.53 or 55. You will be wrong. Because you cannot have this 33 on your burette. You can only have, this is between 0.40. Did you see that now? So, if you want to write your burette readings, you can have this as an average titre, but you cannot have this in the burette readings. That's why I said, pay attention. I'll be giving a lot of instruction. So, if my teacher is working with this, my teacher is saying, oh, these are titre value. My own is to come and pick from this value. Because I can have 22.30, 22.40. So I'll now determine which one. Look at this, I'm picking this now. So I'm picking 22.30. What did I tell you? Raise it up by 0.20, right? So your rough will be 22.50, right? Your first will be 22.30. Your second will be 22.30. Your third will be 22.40. Did you see that now? Now let's add all this now. Divide by 3. You know this is rough, so don't let us use it. Let's add all this now. 22.30 plus 22.30 plus 22.40 divide by 3. Did you see? What I'm getting here is 22.33 centimeter cube, which is what your teacher is working with. I don't know if you are getting that. let's say for example I want to use this now. Don't forget this 22.33 is in between this, because this is what I want to record here. So I cannot have 22.33 inside this place. I don't know if you are getting. Let's say for example I'm working with this. So if I'm working with 22.40, let me raise it up by 0.20. So that will be 22.60, right? I'm working with this now. So I'll say 22.40, 22.40, 22.30. Did you see? These are different tables for different people, for different students. But we are still, our average title is still going to be very closer. So let's have this now. 22.40 plus 22.40 plus 22.30 divided by 3. Here I have 22.37 centimeter cube. Did you see? 22.37, 22.33. Did you see that? We are still within same range, so we are correct. I think you have learned something here. So you don't need to disturb yourself every time. If you do the titration 3 times, this is what you will get. This is the color. This is the color change that will occur, right? So since we know what we are working with and we have titrated, then we can always, complete our tables without stressing ourselves. This is what you will get even if you do the titration, 3, 4, 5 times. This is still the color change that we have. So I hope that is clear now. I hope this is clear. So you can practice this. You can practice it. Just take for example, this is the title value I'm using. Then compute your own. It will be. It's very easy. So, but don't forget that. One technique here, 2 out of the 3 must be the same. Aside from rough, 2 out of the 3 you are writing, which means if you are doing first, second, third, 2 out of it. And some people will be like, sir, must it be that the first and the second must always be the same? No. This 22.3 can be here, 22.4 can be here, 22.3 can be at the other side. But make sure that out of these 3, 2 are the same. There is a mark for concordant values. I hope I've passed my information very clear. So let's go to the solvings now. Very important. So that is just a smart way to outsmart your exam. If you are smart, that's a smart way to outsmart your exam. Okay, so now I said, okay, let's finish up with this. Our volume of acid used, we just do our normal subtraction. So this will be 24.20, this will be 24.00, this will be 24.00. You get that now? So let me now do my average volume of acid used, right? So I'm using this to 24.00 plus 24.00 divided by 2. Don't forget why I'm dividing my own by 2. I'm taking only first, second. Your own, you are taking first, second, and third, because that's how your table look like. So you divide by 3. So which means our average here, average volume of acid is going to be 24.00 centimeter cube. Right? This is very clear now. Okay. Now, I'm still giving instructions, and that's why I said I just wrote a question to cover a lot of areas, okay? So that anywhere they are coming from, we can actually tackle it. The first thing, please pay attention to what we are saying. Watch this video over and over again. Replay it. Let it sink so that you don't make mistakes in your exam. Amount of moles. Look at that. They said number 1. Amount of moles in the average titre. Amount of moles. There is a difference between amount of moles and concentration in mole per dm cube. They are 2 different things. So which means any question on that day, you are saying amount of moles. How do we solve it? Number 1. Amount of moles in the average titre. In average titre. I might not be rewriting the question, I'll just solve directly because of our time. So, amount of moles. If you are new to this channel, you will know the formula for amount of moles. Our amount of moles, which is N, is concentration times volume. Let's write it in full. Concentration times volume, okay, over 1,000. Concentration times volume. Now, the formula for amount in moles is actually concentration times volume. I've always said that anytime we talk concentration times volume. But because we have all these things in centimeter cube, you can see all what we are using, our volume of pipette. Let me write that. Let me write indicator here. Indicator here. Please don't forget it. As specified in the question. methyl orange. Then our volume of pipette, okay, is 25 centimeter. Did you get that? I can see 25 centimeter cube. All what you are using is centimeter cube. Did you get that? So the formula is actually concentration times volume. You get that now? But because we want to convert, that's why we are now doing over 1,000. Because the volume is supposed to be in dmp. Did you get that now? So our N now, concentration of moles in the average titre. Average titre means acid, because that's where our average volume of acid used. So anything that is amount of moles in average titre, anything that concerns average titre is talking about acid. So remember that anytime you are asked to ask amount in moles, this is the formula you are using. So what is the concentration? Let's go back to the question. It's given already. It's 0.100. Okay. So let's have 0.100 times volume of acid. What is the volume of acid? 24.00 divided by what? 1,000. So what's the answer? Let's have our calculator. 0.100 times 24 divide 1,000. That's 0.0024 moles. That's the answer. Did you get that? That's the amount in moles. Amount in moles of in the average titre. Amount of moles in the average titre. I hope this is clear. Amount in moles. This is the formula. I'm repeating that. Amount in moles. So the second one now. Look at it. This is a different question. Concentration of B in mole per dm cube. Mole per dm cube is different from amount in moles. Did you see? Amount in moles, I've given the formula. Mole per dm cube now. What's that formula? Two formulas will come to your mind. The first one is, our mole is equal to mass over molar mass. Let's check if this one will solve it. So mass is the mass given in the question. The mass of the bicarbonate is not given. That's sodium hydrogen transcarbonate. It's not given in the question. And we are looking for the mole. That means we cannot use this, because we cannot be looking for mole and mass same time. So if this will not work, then this will work. Let's have a rule in here. So Ca Va over Cb Vb equals Na over what? Nb. I want to believe this is clear. So from here, the concentration of acid. Don't forget the concentration of acid in mole per dm. That's what we are taking, not the amount in moles. Please take note of this. So here, concentration of acid is given in the question already. Is 0.1. So we have 0.100 times volume of acid. That's our titre value, 24.00 over concentration of base. That's what we are looking for. Concentration of B. Concentration of B. That's Cb times Vb, that's the volume of pipette, that's what? 25 equals to Na over Nb. The equation is given already. You can see this equation is balanced. So we have 1 mole of ACl to 1 mole of sodium carbonate. 1 mole of ACl to 1 mole of sodium carbonate. Did you get that now? So we have that. This will be 1 over 1. This will be 1 over 1. Did you get that now? So from there, what do? We make Cb the subject. So from here, we say Cb equals to cross multiply. We have 0.100 times 24.00 times 1 over 25 times 1. So our Cb will be 0.100 times 24. It's giving me 0.096 mole per dm. That's sorted. Okay. So that's sorted. Number 3. I added this solubility too, because if they come from that angle, we can solve too. Solubility of NaHCO3 in mole per dm cube. Let's take time here so that I will explain something. They said B is obtained by diluting 50.0 centimeter cube of saturated solution. So the meaning of what they are telling us is that after they did all this 50.0 centimeter cube, the amount of mole per dm cube that is there is this. So it's simple. And we know the standard measurement in chemistry is 1,000 centimeter cube. So I can say 50.0 centimeter cube, the amount of mole that is there is what? Is 0.096 0.6 mole per ratio. When we got the concentration of B, it is this. So, which means 1000 centimeter cube, we want to be X. Did you see that? So, if we make X the subject, we are going to have that 1000 times 0.096, okay, over what? 50. So, let's see. 1000 times 0.096 divided by 50. That's giving us 1.92 mole per dmq. I want to believe this is clear. Did you see that? Now look at something again. Or I can still use this to confirm this. The meaning is that the 50 centimeter cube of the saturated solution they did, the number of mole that is there is this. So for 1000, what will that be? And that's why solubility, if you look at the definition, the amount of solute that can be dissolved in 1 dm cube of the solution. 1 dm cube is 1000 centimeter cube. That's what is bringing this 1000 now. Did you get? But I can still use this. Let me solve it here. Just for emphasis sake, I can still use this to still give me same answer. This is my dilution factor formula. C1V1 equals to C2V2. So what is my C1? That's what I'm looking for. Times what is my V1? That's the 50 they gave me. Equals what is my C2? My C2 concentration is 0.096. Abi? Times what is my V2? They said it's 0.096 mole per dm cube. What's the meaning of per dm cube? That's 1 dm cube. And what is 1 dm cube? 1000 centimeter cube. So it will be 1000. Did you see that now? So my C1 will be what? 0.096 times 1000 over what? 50. Did you see? Same thing here. Did you see here? Same thing. So which means the C1 here will still give me same thing. 1.92 mole per dm cube. So chemistry is easy. Anyway, I just solved that so that you see it's easier. Anyone can be used. So for the fourth one now, they said the mass of NaHCO3 obtained by evaporating 1 dm cube of the saturated solution to dryness. The mass obtained. You have gotten the mole obtained. This is easier now. So look at this formula. Mole is equal to mass over molar mass. So I have gotten the mole obtained. Alright? The molar mass. So let's calculate the molar mass of this. Did you get that now? So let's quickly do that now. So we have molar mass. Let's calculate that. Molar mass of NaHCO3. They have given us all the atomic masses in the question. So this is 23 plus 1 plus 12 plus 16 times 3. So this will be 23 plus 1 plus 12 plus 48. If I do this 13, so this will give me 84 gram per mole. Did you see that now? So if it's 84 gram per mole, then this is the molar mass, this is the mole. So we can now say mass is equal to what? Mole times molar mass. Okay? So my mass will be equal to what is the mole? 1.92 that we have gotten times what is the molar mass? 84. So the mass will be equal to 1.92 times 84. That's 161, let's just say 0.3 gram. Because it's mass, so the unit is gram. Very simple. That's if they are coming from the solubility side. These are things we can meet. Why the last question? Volume of CO2 at STP that will be liberated from 1 dm cube of B. So let the camera come here, please. Because this is where I want to bring this from. Now look at the equation. It is this very particular stuff that liberated this CO2. Because the CO3 is here. Did you see? NaHCO3 will liberate this CO2 here. So which means from this equation, 1 mole of this is 1 mole of this. Because we are not seeing anything here, definitely. This is 1 mole to 1 mole of CO2. So let's solve now. So from the equation, we are solving 5 now. From the equation, 1 mole of NaHCO3 is what? We call that stoichiometry. 1 mole of CO2. Right? And since it is at STP, they will give you STP. Of course, they will give us something like this. STP. They will give us molar volume, 22.4 dm3. They will always give us this. So, which means 1 mole of NaHCO3 is equal to 1 mole of CO2. You should know that now. Molar volume of gas at STP. So 1 mole of this will give us 22.4 dm. Did you get that now? So 1 mole of sodium hydrogen thiocarbonate will give 22.4 dm cube of CO2, right? So from this now, which is the base, look at what I'm using now, the base. Look at that. 1 mole of this will give this. So this mole, because this is the concentration of base now, so I'll now say 0.096 mole will give what? X. Did you see? So our X will be 0.096 times 22.4. So let's add that now. 0.096 times 22.4. And that will give us 2.15 approximately dm cube. That's all. That is all. That's all. So if you are following the teachings here, you are making these things very easy. We are giving you instructions, we are giving you tips, we are giving you strategies. These are just, you just need, some of you, when you watch this video, you might not get it once. That's why you have to watch it. Your exam is still some days, to today. You have to still watch and watch and watch. I promised one of my subscribers that I will do something when I'm shooting this video, and let me quickly attend to that. If you need to write this question down, please just write it. I quickly want to do something. I want to wrap up this place because I promised the subscriber I will talk about it, because he sent a question. I was like, chemistry hangout, if the question comes like this, how do we solve? And I said, okay, when I'm doing the video, I will address it. That if the question comes this way too, this one is even easier. I've done this severally on my channel. He said if the question comes like this, A is 0.100 mole. I can remember that question. Mole per dm cube of HCl. And he said B is, he said, okay, 2 gram of 250 centimeter cube of X, yes, that's what he said, CO3. Now, if the question looks like this, of course, if the question looks like this, they might be telling you to get, just like concentration of A, but the main emphasis will be for you to get this X. How do you do it? Let me just quickly talk about that in a few minutes, then I'll be done, because I promised that I will do. So, in questions like this, they will tell you, one of the things they will tell you to calculate is concentration of B in mole per dm cube, then they can now ask you to look for the value of X. You see this value of X, they ask you to look for it. You have to solve a lot of things before you come to the value of X. So let's talk about that. I've said this before now. These are simple things. That's why all these questions are the same. They are just, trying to maneuver you, but it's still same question. Why did we say same question? Okay, so now look at it. It's a concentration of B. So we cannot use this. Mole is equal to mass. But I'm just trying to, because I promised the subscriber I will actually do this. Just I'm running quickly to do that. So if you look at this now, the mole now, we cannot use this. So what are we going to use? VA over CB, VB will be NA. The question can actually come like this too. It's a good suggestion. The question can come like this. So what is the CA? That is 0.100 that is giving times VA, that's our title value, 24.00 over CB. You can see it's still the same thing with that. Just follow the normal teachings we have done. No matter the way, times 25 equals to 1 over 1. Is that not the same thing? It's just like this thing that we have done. So which means our CB is still going to be 0.096 mole per dm cube. Did you see that now? Same thing. Now this is where the subscriber is concerned about. How do we get the value of C? For us to get the value of C, you need to now look for the, we want to look for this one now. So for us to look for the value of X here, for you to get the value of X here, you need to now calculate the molar mass. So how do you calculate the molar mass? It means that you must know the mole which you have gotten, and you must know the mass. Did you see that now? Now if you look at this, they said 2 grams of 250 centimeter cube. I've said that before, that the standard measurement in chemistry is 1000. So which means we need to convert. Let's say for example, they wrote it in dm cube now, we can use it like that. So I need to convert this mass. So I will say 2 grams in 250 centimeter cube in 1000 centimeter cube, it will be what? to be x. Did you see that now? So from here, what are we going to do? Cross multiply. So this will be 2 times 1000 over 250. Definitely this will give me 8 gram per dm cube, or 8 gram. This will give me 8 gram now, because it's 2 in 250. So which means we are going to have 8 gram. Just like you are multiplying by this times 4 will give me 8. This times 4 will give me 1000. Did you see that now? So you still say, but if they are giving me 8 gram per dm cube here directly, I would have used it like that. So I've gotten the what here now? The mass, right? The mass concentration. I can now use this. So the molar mass is now going to be mass over mole. Should we see it now? So we now have the molar mass to be, what is the mass? The mass is 8 gram per dm cube over the mole. You can see it's easier, 0.096. So let's have our calculator. 8 divided 0.096. That will be 83.33. So the molar mass is 83.3 gram per mole. Is that not? What did they ask us to look for? Value of x. So that's simple now. So I can now bring this and say SHCO3 equals to 83.3. Or let me say approximately 83. Let me just take a whole number. So let me take a whole number. So x plus, this one is 1, plus this one is what? 12 plus 16 times 3 equals to 83. See, that's mass. Look for x. X plus 13. 16 times 3 will be 48. 48 plus 13 will be what? Will be 61 equals to 83. X will be 83 minus 61. So x will be 83 minus 61. So that's around 22, which is closer to 23. You know, this is titration. So can you see 22? So which is closer to 23, which means S is sodium, because sodium has the atomic mass of what? Of 23. So that's how it looks like. Did you get that now? So if the question comes like that, this one is easier too. Just follow the same principle on the channel and we're going to get it. Please, I advise you to watch this thing over and over and over again. You are just new to this channel, subscribe to this channel, turn on the notification bell so that when we upload any video, you are going to be notified. Wish you success in your exam. Thank you so much. God bless you.